Okay, last class Abhishek was telling about some evolution of the web services, revolution with some different web service definition languages. Okay, we will continue with the web service and the primitive SOA. The primitive SOA means earlier what the features were included to our web services. Okay, and after the primitive SOA, we will approach towards the contemporary SOA. Okay, so if we will compare the chapter 3 and 5 and their relationships in between the two, some questions were asked in the chapter 3, that is how the services encapsulate the logic, and that answer is given in our chapter 5. Some questions were asked in chapter 3 and their answers probably we can find in our chapter 5 in the primitive SOA. In the fundamental SOA, how services encapsulate the logic. Then we can say these services can encapsulate as a web service, and how this service can relate. It is can be with the service descriptions with web service description language WSDL. And how service communicate. Some questions were asked, and here we have the answer with the messaging format. And what is that messaging format? The SOAP, Simple Object Access Protocol, the SOAP messaging format. Then their web service framework. Okay, so it is a technology that a framework is a collection of some things or web of things, and it can include one or more architectures and technologies, concepts, models, and even some new frameworks or sub-frameworks. Specifically, this framework is characterized with a lot of characters. One by one, we will cover. First one, the abstract part, then the concrete part. First one, the abstract part is it is an existence or defined by some standards of organizations and implemented by some technology platforms. These standards are with some associated with some organizations and they are implemented with the technology platforms. So we already told these web services are interoperable, so that we can implement with different platforms. The core building blocks that include the web service, service descriptions, and messages. The core building block we will discuss with a graphical representation how these
Sir, you are not audible.
Sir, you are muted.
it is network dependent if you will be mute or not. I think now it is audible.
Yes.
Yeah, Somo, am I audible?
Ah, yes, sir, audible.
Okay. So we are telling about the messaging framework with the SOAP technology and their concepts. Then some service description, registration, and discovery architecture, sometimes realized from UDDDI. So after the SOAP technology, that is a messaging format, we will go for the registration, their discovery, their description through the UDDI, Universal Discovery, Description, and Integration. A well-defined architecture that supports the messaging patterns and compositions. And also we have another graphical representation, pictorial representation with the composability. How the services are composing to provide a unique standard solution. A second generation of web services extensions, also known as the WS specifications. These are continually broadening its underlying feature set. We will cover later. Now, first on the service. As a website, first answer for our question, how services encapsulate the logic. It is with the services, and that what is that service? As a web service. The first answer. So these web services are mainly classified as two types. One is your temporary classification, then permanent classification. And the temporary is based on the assumptions that it will be implemented or the processing will be done during the runtime, and the permanent classification based on the application logic, and it provides its role and its assumption with a solution environment. First we'll go for the solution environment. And in a temporary classification, it assumes during the runtime. Then service roles. The web services have different roles according to their different context. If context is different, their roles will also differ. Like we have different web service SOAP is working one thing. The rest is different role. XML signature has different role. XML encryption has different role. So according to their aspect of context, their roles also change. A service is therefore not labeled exclusively as a client or server, but instead we can consider it as a software that can capable of altering the role depending on its processing responsibility in a given scenario. The web service is invoked by an external source. So how can we invoke this web service? Using some external source. Just we can say a service request or service provider. One is invoked means with a service request. The web service provides a published service description offering information about its features and behavior. So it has some definitions about that the web service. So how we will define it and publish it? It has some description criteria that has the information about its feature, their behavior, their activities, roles, everything are described in the service description of any web service. Then the service provider role is synonymous, very similar with the server role in the classic client server architecture. Now, as a recipient, it is getting a request from other service, okay, and it will provide a service as a response message. As the recipient of the request message, the web service is classified as a service provider. Here you can check the 5.2 figure. Once it will receive the request from other web services, then it will process it and provide the service and send a message, and the message is your response message. And what are the terms in this context we are using? Now the service provider entity, the organization or any individual providing the web service. That is the service provider entity, mainly provided by any organization or any individual organization. Then the service provider agent, that is, they are sending the response on behalf of its owner or on behalf of a organization. So in that case we need a service provider agent. Then service requester. Previous was the service roles, what the role should be. Then the service requester. It is also a web service that sends the request to the service provider to get the response for its requirement. Any unit of processing logic that capable of issuing a request message that can be understood by the service provider. So, any unit of processing logic or any requester that is capable of issuing a request message. So it should have the processing unit inside it that has the tendency to issue a request message and that can be understood by the service provider. So what it is sending as a request, it should be properly clarified by the service provider. Then a web service is always a service provider but also can act as a service requester. So web service is always a service provider, but I just now told that it also can act as a service request. The web service takes on the service requester role under the following circumstances. So what the circumstances we will discuss. The web service involves a service provider by sending a message, by sending its own message. And the web service searches for and assesses the most suitable service. Once getting the request, in the other end, the service provider is there. That service provider is nothing but also another web service that searches for and assess or evaluate the most suitable service provider by staying available the service description, by studying the description, what the requirement is from the requester, and by analyzing it, by assessing it properly, it will send the most suitable service response. And the service descriptions and service registries are covered in the service. Next we will cover. Then the service requester entity, it is the organization or request the web service, and the service requester agent, it is again on behalf of the organization or an owner, it is sending the message. Now here the service requesters, the sender as a application component, as a web service, as a mobile device, entirely they are sending some messages. The entire part, the dotted circle is there. In that dotted circle, you can find the sender is requesting the message is classified as a service requester. These are the service requesters in any web service: the application component, the web service itself, and the mobile devices associated with the client. These three are classified as the requesters and send the message to the service provider to get the response. Now, in the field of TLS and RELCO, if we will consider, in RELCO, who is the service requester? Now, the invoice service submission service. And for TLS, transit line system, who is the service requester? Now, purchase order service. The TLS purchase order service will send a request to the order fulfillment service. It will provide a service response to that message. And the invoice service, once the order is fulfilled, then it will request for a invoice service submission to the account payable service submission of TLS. You can check. For TLS and RELCO, there are two service providers and two service requesters. And for RELCO, who is the service requester? The invoice service submission service. And for TLS, it is purchase order service. Okay. So, the next we'll cover another part here. The intermediary service. In between the service requester and service provider, we have a lot of intermediary services. They may alter your messages or may not alter your messages. It is highly dependent on the network and which network you are using. So here, who is the ultimate sender? Your ultimate sender is your service requester. And who is the ultimate receiver? Here it is your service provider. So in between the ultimate requester and ultimate provider, or ultimate requester, it is also known as the initial requester. And in between the initial requester and the final or ultimate service provider, there are a lot of intermediary services. They may change or modify the message according to the requirement. So this is an intermediary service transition between the two service provider and requester for processing the message or altering the message. So these are again two types. These intermediary services are two types. Basically, it is a passive one or a active one. If you are thinking that in a network there are intermediate services are there available and these are passive one, then it will not affect the content of the message. So it will send the message without changing or without altering its contents, but it will provide a route or it will route the logic used in the messaging path. So it can decide the routing path for the message, but it will not change any content. But if you consider the active intermediary service, here they may change or alter the message informations in the message. So, and they can process and modify the message prior to the forwarding it. So it is a active intermediary service. So they will change the message and change according to priority. So here the web service acting as the initial sender and ultimate receiver. Just now I talked about it. The initial sender means the initial requester, the service requester, and the ultimate receiver is the ultimate service provider. And in between there are multiple intermediary services are there, whether they are passive intermediary service or the active intermediary services. Then if we'll consider the TLS and RELCO, and in between TLS and RELCO, one it is requesting, which one? The invoice submission service. The requesting as an initial sender to the account payable service for its invoice. Then there is in the TLS there is a intermediary service. And what is that intermediate service? A load balancing service. Okay, that will manage the load for all the services. And this TLS load balancing service acts as a intermediary in between RELCO and TLS. Also, in the composition services, what its role is actually composition member or composition service. Now, it will compose multiple number of solutions, individual solutions, and composite and provide a final solution for any request. Okay, so here composition member 1, composition member 2, and composition member 3 all are initially they will compose the solutions or compose their web service values or assess the values, then it will send the response for the composition. The web service need to be designed with service composition in mind to be effective composition members. And it is very important that the service in a service oriented environment, it is governed by the web service composition extensions or web service star. These stars are the extensions, and the composition is also extension. WS web service composition, that is extension. And one of the example is web service BPL, business process executing language, which introduced the related concepts of orchestration and choreography. Now, the account payable service that enlists the transit line system service in a service composition. So, related to the previous example, here it is composing the two services. Which one? The account payable service. It has two compositions, the vendor profile service and the ledger service. It will compose the two services and send the response to the request. You just compare this context with the previous one. Okay, how the composition is working. So it is composition 1, 2, 3, and their final solutions it will provide to the requester. And the similar to TLS, it will compose the services, ledger service and vendor profile service. And these two will be composed, then will be provided to the account payable service, and the ultimate solution will be sent to the whom? The requester who has requested for the service. Now, the service models. Okay, here first one is your business service model and who are the utility service models. We will compare business service model and utility service model. So within Ensure service oriented architecture, the business service represents the most fundamental building block. Okay, which are the business service, and it encapsulates a set of business logic. Ultimately, it encapsulates what? The set of business logic within a well-defined functional boundary. Then it is fully autonomous, but still not limited to executing in isolation. These are autonomous, but they are not still permitted or limited for execution in an isolated environment. As business services are frequently expected to participate in some service compositions. Since we are expecting that they will participate with some service compositions, the business services are used within the service oriented architecture with the following criteria. With the following criteria. Okay. So, what are the criteria? As a fundamental building block, then to represent some corporate entity, and to represent the business process logic, and as a service composition member. So these are the criteria which we include in our business services that is used within the SOA. Now, after the business model, business service model, then we have the utility service model. Then in the next slide, we'll categorize who are the business models and who are the utility models. So come to the utility service model. In the utility service model, these web services are designed for any potential reusability, utility. So it will help ultimately for reusability. That is the potential reuse, and can be classified as a utility services. And these are used within some SOA as follows. And what are the criteria? Just previous slide told the criteria for business service model. And what are the criteria for utility service model? So a services that enables the characteristics of reuse. Ultimately, it will provide the characteristics of reuse. Then it is solution agnostic, means in the intermediary services, means it is less dependent or platform independency is there. So they can able to work with different platforms, solution agnostic, and as a service within the highest degree of autonomy. So just in the previous slide I told, although they are autonomous, but still they are not limited for the isolation. They are autonomous but not implemented in an isolated environment. Okay, just remember this thing. Autonomy is there, but they are not isolated. So one of the case study, we will compare who are the business services and who are the utility services. So in the examples, we have gone through some fair chapters earlier. Now we will compare this business service model and utility service model who are coming under. First, account payable service. You just remember here, only two utility services we have: internal policy service and a load balance service. Okay, in the exam you may confuse. So try to remember the internal policy service and load balancing service. These two are the utility services. Okay. And who are the business services? Your account payable service, invoice submission service, ledger service, order fulfillment, purchase order service, and vendor profile service. And in between the account payable service, we have two sub services. What are they? The ledger service and vendor profile service. Already we discussed in the earlier slides. Okay. Both are again business service models. Only two utility services. Try to remember the internal policy service and the load balancing service. Hello, Vidyasagar. Are you comfortable with this presentation or not? If you any doubt, you can ask at any time because you are beginning this class today. Hello, Vidyasagar, are you there? Respond, Vidyasagar. If your mic is also not working, you can just send a message to me. If anything is, if you have any doubt, you can ask. Yes, sir, joined Vidyasagar and then respond me with some tar year. Mic respond karo, tar mic काम करने, so WhatsApp message देके respond करो. So yes, sir, my mic is not working.
Why did you then join? Why did you join? You have not joined since September. Then why did you join today?
And now I'm asking some questions, he is not responding.
Why did you join today? With all your wrong things in your mind as well as in your with your facility. You have a virus in your mind. That's the whole problem. You are suffering because of the virus. Who will help you? Some virus you have.
Vidyasagar, you are still not responding. Your audio is mute. Before attending the class, you should have the proper assembly of all your.
Next class, you have to show your face and keep your mic on. You are not allowed to make it mute. Wrong boy in my class. Yeah, you will suffer. You will suffer one more year because of your virus. Nobody can help you. You don't want any help. Anyway, your time over?
No, sir, I'm continuing. I'll just manage, I will finish today.
Right.
So these are the case study with our business service model and utility service model and how we will categorize who is coming under utility service model and who is coming under business service model. Okay. Now the controller service model. Okay. Here ultimately another we have the role of composability. The controller service model. The service compositions are comprised of a set of some independent services. Okay. And that each contribute to the execution of the overall business task. The assembly and coordination of these services is often a task itself and one that can be assigned as the primary function of a dedicated service. Listen. So here we are assigning a task for any primary function and dedicated service, and the secondary function is that is fully capable of execution of a business task, and the controller service fulfill these roles and these roles or these parent service to other composition members. The controller services are used within the SOA, which are there to support, just like the previous slides I told, the business service characteristics, then the utility service characteristics. Now the controller services within the SOA. So it supports and implement the principle of composability, the very vital thing. Then to leverage the reuse opportunities, it helps to improve or increase the reuse opportunities. Then to support the autonomy in order services. So in ordering service with other services, it provides the autonomy. Okay. So in figure 5.2, you can check we have a master controller service and a sub-controller service within the master controller service, which has a lot of business services and utility services. So in the master controller service, we have the business services, the another business services 1 or and 2. Also it has a sub-controller service in which there are again some other business services as well as the utility services. Okay, so how these are composed or reused by using the controller services within the SOA. Now, just compare the previous slide picture with the TLS. Okay, transit line system. Here, the account payable service, it will act as a control service in which we have the business services. And who are the other business services are present in it? That is your vendor profile service and the ledger service. These are the business services associated with your account payable service, and this account payable service is your controller service. Now the service descriptions. This part of SOA provides the key ingredient to establish a consistently loosely coupled from communication between the service implemented as a web service. So it provides a loose coupled communication service. Loose coupled means that is the less dependency will be there between the services. Then we can say the services are loosely coupled. Okay, and that can be implemented with the web services. For this purpose, the description documents. For always we have a description document in the previous slide already told. Let service A requesting to service B. So request A should have the proper description about the web service B. Then only it can send a request. If you don't have the proper description, just I am telling you example. If you are suffering with some cardiac disease, and if you don't have an idea about a cardiology doctor, and if you will go for a nephrology doctor, what type of service you will get there? So you should have the proper description, proper definition to whom you are going to request. What the service you can get, you should have the proper description. In the next slide, I will just show you. So if you are going to a cardiology doctor, means you should have the idea that what type of doctor he is, what type of treatment he is doing, everything proper idea you should have with you. And if you have some cardiac problem and if you will go for any dermatologist, what the treatment he will provide to you. So you should have the proper definition about the services to whom you are requesting. Here you can check. In figure 5.14, the web service definition language that defines the loose coupling between the services. Here, the service A, it is requesting service B. Just please look at the figure, the 5.1 for slide 24. Here, the service A is requesting service B. Okay, and in the message, it should have the proper definition for service B. All the proper definitions will be there in the message for service B, web service definition for service B. And similarly, in the service B also have the proper definition for service A. Okay. Then only you can request to the services or the service providers. Now, with a case study, if you will consider, and the case study we are considering here with the RELCO and TLS. So, RELCO is to design the business to business web services. ଯଦି ଆପଣଙ୍କୁ କହିବେ ଯଦି କହିବେ ସାର୍ ବସୁଛନ୍ତି କହିଥାନ୍ତୁ କଥା ଓହୋ ଆଜ୍ଞା ଏ କାଳନ୍ଦୀ okay. Here in our case study we are considering the RELCO and TLS services. For RELCO to design its business to business web services in full compliance with the TLS services, RELCO acquires the WSDL service description that is published by TLS. So TLS will publish it, its requirement, and these descriptions will be sent to RELCO. This definition file then is used by the developers to build the invoice submission service so that it can process the swap messages in accordance with the service interface requirements defined in the TLS description. Okay, so directly we come to the figure here. In the RELCO and the TLS, okay, first RELCO will send a request, the invoice submission service, for the account payable service, and the purchase order service of TLS will request for the order fulfillment service. So all the definitions, all the descriptions about their service, what type of services they are providing, should be properly defined in the message. Then only you can get a proper response or a suitable response from your service provider. Then the service endpoints and service descriptions. Okay, these are categorized with our abstract description and concrete description. Okay, and the abstract description is your port type or the interface associated with your services, their operations, and the messages. In the concrete description, it is the entire binding process, all the entire templates, the binding templates process, then the port or endpoint and the services. The first one we will be briefly consider the abstract description. Here it establishes the interface characteristics of the web service without any reference to the technology used to host or enable a web service to transmit the messages. And by separating this information, the integrity of the service description can be preserved regardless of what changes might occur to the underlying technology platform. Now, with the port type, the operation, and the message, these are the components in your abstract definition. Okay. The port type section, it is a abstract description that provides a high-level view of the service interface by which we are connecting to the another service. You should have a service interface. Okay, that is also known as your port type. And by sorting the messages, as a service can process into the groups of functions, also known as operations. Next, the messages are web service rely on the exclusively based on some message-based communications, the parameters and represented as messages. Therefore, an operation consists of a set of input and output messages. Obviously, the operation that consists of some set of input and output messages. The term port type is also renamed as interface in the next version of WSDL. So in the WSDL 2.0, we have a interface that is renamed to interface. Now the next one, concrete description. So for some web services to be able to execute of any logic, it needs for its abstract interface definition to be connected with some real implemented technology. So because the execution of service applications are always involved with some communication, the abstract service interface need to be connected to a physical transport protocol. So similar to the abstract description, here the elements are the binding support and services. A WSDL descriptions binding that describes the requirements for a service to establish some physical connections with the service. In other words, the binding represents a possible transport technology, the service that can be used to communicate. So here binding is a some possible transport technology that helps to communicate. Then SOAP is the most common form of binding. It's a very simple one is a binding technique is SOAP. SOAP web service, simple object access protocol. So it provides also a binding service. It is another web service. Here the messages, their contents with the header block, with the body part, all will be binded to it. But others are also supported. A binding can apply to an entire interface or just some specific operations. Then metadata and service contracts. Okay. Some data about data means if any data have some information for other data, that is considered of metadata and the service contract. These are associated with our WSDL definition, web service description language definition, XSD schema, XML schema definition, XSD, then their policies. And each of these three service description documents can be classified as a service metadata, and that provides the information about other services. First one is your service contract. It can refer to some additional documents or agreements. This contract is some additional agreement or contract that is expressed by some service descriptions. For example, a service level agreement, SLA, that is agreed by some respective owners of a service provider, and its requester can be considered as a part of it. So we will go to directly to the figure here. A service contract, how it is given. So it has some definitions like the abstract definitions and the concrete description. And the abstract definition has its own elements or components, and the concrete definition has its own components. And they have some policies and some agreements and some contracts. And what are they? The XSD schema, their agreements, their policies, and their legal documents. A service contract that comprises of a collection of service descriptions and possibly additional documents. Now, the semantic descriptions. These will include the service semantics. So how a service behaves under some certain condition, how a service will respond to a specific condition, and what specific tasks that the service must be suited for. So these are the ideas or questions that may arise in a semantics, service semantics. The semantic information is usually of greater importance when that deals with some external service provider. So we'll give the priority only when these semantic informations are dealt with some external service providers, and where the knowledges and other party service are limited to the information service that owner decides to publish. Then the service description, advertisement, and discovery. As the amount of services that is increased within the outside of organizations, mechanisms for advertising and discovering the service description, it may become necessary. So again, these are with some repository, and that allows human to locate the latest version of the known service description. And these all are associated with your UDDI, Universal Description and Discovery Integration. So first to locate the latest version of the known service description. The next one to discover. Okay, first universal description, discover, then integrate. Okay. So then the discover some new services that is meeting our criteria. Then when the initial set of web services standards are emerged, So when the we'll get an initial state of set of web services, this will eventually taken into account for the integration. This is why UDDI formed part of the first generation of web services. So in the very earlier, in the primitives, UDDI is formed with its standards. Though not yet commonly implemented, UDDI provides us a registry model with what describing. So ultimately, UDDI provides us a repository. Here you can find it is act as a repository. Okay, where it has a lot of service candidates, and what you are searching, what a solution is searching, what a service is searching, everything is there inside the service repository. Okay. Next. Then public registry, which is available in the public domain. Okay. So these public registries accept the registrations from any organizations. These are not private to any individuals or any organizations or any particular entities. So these are public registries, and the registration is from many organizations, regardless whether they have any web service to offer or not. Once signed off, the organizations acting as service provider entities, and that can register their services. Then the private registries, and this can be implemented within an organization because they have their own policies for the registration in the UDDI, and that provides a central repository for the description of all services the organization develops, their leases, and the purchases. And the next one is your business entity and business services. And here the each public registry consists of a business entity and containing the business profile information about the organization. So ultimately we have three variety of registries where we can store and access the services. That is your public services, private registry, and the business entity and business services. Then the models are the core components of the UDDI. The T models, the template model, the main template of any model is always available in the UDDI that represent the unique concepts or constructs and are used to describe some compliance with a specification, a concept, a category or identifier system or a shared design. And the basic structure of a UDDI business entity record. So now the TLS service, with our example with case study, the TLS service registry that contains pointer to current TLS web service definition. And the service registry has the purchase order service, the account payable service, all the load balancing services, all are defined in their services and stored in the service registry. And the next one is your messaging technique. Okay. And it is with your SOAP. The last one is your messaging technique with simple object access protocol. It is a SOAP messaging format, you can say, because of all communication between the service is message based, and the messaging framework chosen must be standardized so that all services, regardless of the origin, use the same format and transport protocol. So first, the structure of the message, what it includes. Now it has the body part, that is the main part. Then another one is your header part, and combining this header and body, we have the enveloping part. Then every SOAP message is packaged into a container no less than envelope. So all the header and body part will be combined into the package, and that package is your envelope. And much like the metaphor, this consists of the envelope is responsible for housing all parts of the message. So it is responsible for all part of the message. All part means only header part and body part. And this is the main basic structure of any SOAP message. One is a header where the main important information of the receiver will be there. And the body part is the main important contents for the processing. Okay. So it has a header part, message part, and that message body is inside the body, and the header blocks. It has the IP address or any pointer address will be there. Now the first one is your header block. Okay. So the example of type of features a message that can be outputted with the using the header block that includes the processing instructions that may be executed by the circuit or intermediaries or the ultimate receiver. So in their header instruction or in their header blocks, it has a set of instructions, and these instructions may be executed by the service intermediaries or the ultimate receiver. Just like I told, in between the initial sender and the ultimate receiver, we have some intermediaries. So who can process, or the set of instruction processing instruction for whom? Now in between the initial sender and the ultimate receiver, they can process it, or the ultimate receiver will process it. Then routing or workflow information associated with the message. Then the security measures implemented in the message. Reliability rule, their context of transaction management, and their correlation of information. So all these things are described in the header blocks. Now, if you consider the RELCO, so here the invoice submission message, it has the invoice document, account statement, and the pricing formulas. So in a single request message, it will send all the contents. Okay. So the RELCO invoice submission service packaging the contents and 3 documents into one sub message. So it will bind, it will, previous slide told, it can also act as a binding service. So it will combine or bind all the documents for invoice document, account statement, pricing formula, then take it into a single message format. Then nodes. And here ultimately this node is a swap node, and that swap node will help to transmit the swap message received by the service logic. So although web service exists as a self-contained unit of processing logic, they are reliant upon some physical communication infrastructure to process and manage the exchange of swap messages. Every major platform has its own implementation of a swap communication server, and as a result, each vendor has labeled its own variation of the pieces of software definitely. In abstract, the programs that service used to transmit and the service swap message. Okay. Now, node types. Similar to the normal sender, receiver, intermediary, receiver, it has also some swap sender, swap receiver, swap intermediary, sender and receiver, initial swap sender, and ultimate swap receiver. Okay. So swap sender means a swap node that transmits a message, or swap receiver that receives a message. And very similar to the initial means the very starting one who is requesting, and the ultimate one is the last or final one who is receiving it. So it is a node service provided by the swap. And the invoice submission service will send through the swap sender node, and that will send a request message to the swap receiver node, and that swap receiver node will provide the information to the account payable service. So in between the invoice, previously it was sending through the directly without, if there is any no messaging technique. So directly we are requesting in invoice submission service, account payable service. So now we are sending through some swap nodes. Previously we are also sending some messages. They are directly reaching to the receiver. But here we are intended to incorporate the swap node. Here, a list of intermediary swap nodes in between the swap sender node and the swap receiver node. Okay, so this is a typical example of it. Now, it is a message path consisting of 3 web services. Who are the web services? The service requester, it is also a web service. The service provider, it is a service, web service. And the intermediate service, it is also a web service. So in between the three, they are just sending the message through a messaging path, and in between the three web services, the requester will send a message to intermediate service, and intermediate service will check the message if according to its authorization, if whether it is a passive intermediate service or a active intermediate service, and it will send to the provider. So here the path is defined in between the three web services. Next we'll see the path which is decided dynamically during the processing or during the runtime. Here there is an initial sender, then it is sending the message to a intermediary services. So before reaching to the ultimate service provider, in between them there are multiple number of or n number of intermediary services are there, and also different paths are there, and which path is to be decided. So that will be decided by the router. So the router will here act as an intermediary service. There, whether it is a passive one directly sent or to change its path, all the things will be defined in it. So this path will be decided during the runtime. Okay. Okay, this is the completion of your chapter 5, and in next class we will try to cover which one? Chapter 6. Chapter 6, there are contemporary SOA. Okay. In this class, we are considering with some primitive SOA, the earlier versions. And in the next version, that is a contemporary SOA, we will cover it. Okay. Everything is okay? Hello.
Yes, sir. Yes.
Okay. So anyway, I want to, no need to take your attendance. I will just download the Excel set, attendance set. Okay, thank you. The next class is on Monday. Monday, na?
Yes, sir.
Yes, sir.
Okay. Thank you for giving your precious time. Okay, bye.